Good evening. Jump scare complete. Okay. So what did I say I would do? I said I was going to look at thermometers and whispers maybe. But step one, let's just run cargo clippy and double check where we are. Yeah, I thought so. So last time we were editing, I did not have clippy running. So there are some things that we may end up fixing as we go, but we don't need to worry about that really for now. What we're actually interested in doing is looking at those puzzle kinds. So let me bring us in. There we are. Okie dokie. I talked about two kinds of constraint that I thought we might be able to handle, and they are thermometers and German whispers and Dutch whispers, or whispered lines. And the reason that I think we can handle those is because they're still only interested in the relationship between cells. So on thermometers, if I just go into solving mode for a moment, what we're interested in is the relationship between the cells along these lines. And the rule in thermometers is that starting at the bulb, numbers must strictly increase. So if we just consider here, for example, if that was a 4, that would have to be a 5 and that would have to be a 6. Now, the 4 there would be a problem because, you know, we can go up to a 5, we can go up to a 6, but now what are we going to do to fill that? We can't. So the maximum, if we consider this one, is that would be a 3, 4, 5, 6. But now, okay, 3. Well, we can't do a 4 there, so we'd have to do a 5. We have to do a 6, and now we've got 2 spaces spare. So what thermometers do is they force you to look at your lines and to work out what's possible up and down the line. I.e., this cell can't be as low as the highest value that this cell can be, and this cell can't be as high as the lowest value of that cell can be. This is just, it's a less than relationship, just like we had with the minimum fortress cells. So if we look at this puzzle and we think for a moment, 1, 2, 3, 4, 5 long. It's not the longest. 1, 2, 3, 4, 5, 6 long. So this thermometer actually immediately locks us down to be 6, 5, 4, 3, 2, 1. We don't have any choice in the matter. Now these two cells have to be higher than 2, and they can't be 3 or 4, so they're going to have to be 5 and 6 in that order. Which leaves 1 and 2 there. And 1 and 2 and 1 and 2 leaves 1 and 2 there. That 1 looks across and gives us the 1 and the 2. And we've got a 3, 4 pair there. 3, 4, 3, 4. So we've got 3, 4 here. And we've got 5, 6 there. And because we're on a thermometer, we know which way round they go. They go that way round. Now, 1. The smallest that can be is a 3. If it was 3, 4, 5, 6, that locks in our thermometer again. 5 looks up, 5 looks across. There's the 5. There's a 3, 4 left in the row. There's a 4 there. So that's a 3, that's a 4, that's a 3. And this is a 2, 4. There's a 4 there. So we've got 2 and 4. And we've completed the top 2 boxes. The 1 looks down here. So there's going to have to be a 1 there. The 6 looks down here. So there's going to have to be a 6 here. The 6 looks across. We've got 1, 6. That 1 looks across and gives us 2 and 1. Here, we're still looking for 2 and 3. So they'll have to go that way around. Looking down here, we've got 1, 2, 3, and 6. So we need 4 and 5. The 5 looks across. 4 and 5. That is a 3, 4 in the row. There's a 4. Sorry, there's a 3 there. So that's the 4 and the 3. So we need the 1 there. And now here we have 2 cells left, and they are 2 and 6, which means they have to go that way around, either by what was left in the columns or by the thermometer. So that's how we solve a thermometer-like puzzle. And this is one of the easier thermometer puzzles from the advent of Sudoku that I made. So we're going to use this one as our initial thermometer test puzzle for feeding into Kaji in order to get somewhere. So let's embed the solution, clear it, and have a look at the JSON. We can see here that there is a thermometer top level object, which is in fact a list. Each element in that says lines, each lines, so that's a list of lists of cells. Weird, but this structure here from lines down is very similar to the palindrome lines that we saw when we were doing palindromes. So let's capture all of that. I'm going to throw that back onto my other monitor so that it's out of the way. And we are going to have what's called frost. The autocomplete there was showing that I had thought about putting some sample puzzles down in JSON first. That one said medium German whispers. Let me just very quickly yoink back my web browser to show you. Instead, I've made a smaller German whisper test puzzle, which we'll use later, hopefully, assuming we get there. Right. We now have our frost puzzle. So let's add it to our tests and also set it as our default. So we're going to edit Kaji main bin source main. And we are going to load frost. And while we're here, we're going to grab the test cases and we will write a thermo test case of frost. You'll notice that I'm still not quite used to Helix, and you'll have to forgive me for that. Okay. So if we cargo run, we fail to solve. And fairly obviously, the reason that we failed to solve is because we haven't actually done anything with that thermometer. One thought that I had is it might be nice to force our JSON so that if we try to load something that we don't have the information for, we will fail to parse. So let's do that first. Going to close that buffer and let's go and find ourselves the fpuzzles loader. And one of the ways that we can do that is with a Serde attribute. And the attribute that we want is, let me find it. Oh my goodness me. Deny unknown fields, that's it. So that will force everything. And we can see that, of course, the only failure is thermo. And the reason it's failed is because we have this unknown field thermometer. So let's go ahead and add a thermometer option here. And just like the palindrome up here, this is a vector of fpuzzles line. Lines, sorry. So we've now got the thermometer loading. The next thing that we need to do is convert it. And now in palindromes, we just pushed clone pairs. In the XV pairs, we just pulled pushed cell pairs. The minimum and maxima, we specifically called them minimum and maximum because we wanted to do something clever with them. I think I want thermometers to be kept as their lines in case we need to add clever logic later. So let's also go ahead to Kaji rules and grab the puzzle data. And let's find our rules here. So what we're going to have is thermometers, which are vectors of Sudoku grid. Well, they're vectors of U-size pairs. And it's row col 1 based. And that's probably enough data-wise for us. We don't need to be any cleverer than that. Oopsie. So let's now process our thermometers for thermo in. If you remember, every thermometer had potentially multiple lines. So we're going to go for line in thermo.lines. And we're going to go grid rules mute thermometer push line into iter map. Given a cell ref, we want the row and column. And we want to collect that. So that's done the thermometer conversion. Next, we need to process it into the constraints that we want. So let's bring up the Sudoku rule. Now, I think that thermometers can be processed as yet more cell pair relationships. And the reason that I think that, and let me just bring the puzzle back so that we can examine it again. The reason that I think that is because effectively all we need to do is we need to say that cell is less than that cell. That is less than that. That's less than that, and so on. And then allow the fact that we've designed things so that if we have that cell pair and that cell pair, it detects this as a pivot and performs logic based on that, which admittedly is less interesting for that one, but it's definitely relevant for that and for that. So I think we can do it just as pairs of value orderings. So let's try and do that. For thermo in, remind myself how I get to our rules. It's raw.rules. So this time we have the cell sets that we need. So we're going to go for A comma B in, well, in fact, yeah, for A comma B in thermo.iter.copied.tuple windows. I hope. There is a method circular tuple windows. There is no method tuple windows for copied. Do I not have iter tools imported here? I don't. Bring it in. There we go. Right. Yes, yes, yes. Unused A and B and all of that joy. So we have our cell pair. So all we're going to go, let's say, let mute thermo pairs is a vector. Thermo pairs push cell pair relationship. Oopsie. we need to push the 2 cells first. So the first cell is going to be rows A.0 minus 1, A.1 minus 1. The second cell is B.0, B.1. And then the third item is a cell pair relationship less than. Okay, so we're iterating along the thermometers, setting the less than relationship up. And let's just double check that the thermometer sequence is in the order that we want it to be. Let's pick a thermometer. So it's saying the first item in the list is row 6, column 3, and the last item is row 2, column 6. So row 6, column 3 to row 2, column 6. That works. Okay. I think that's set up everything for thermometers. So it didn't work. So let's actually just have a look and see what's happening. So we're failing to solve. Well, realistically, I haven't actually included the thermo pairs into the cell pair rule. So chain thermo pairs. Ooh, we panicked. That is less than handy. We panicked at pointing. Something went wrong collecting regions. So we've done something very strange here that we're going to have to track through. Oh, that does not please me. Let's bring up the... I'm going to put the puzzle on my other monitor while we go through this. Actually, no. I'm going to be nicer than that. I'm going to get the puzzle onto what you guys... No, you guys can't see that now. Yes. No, I've done the wrong thing. There we go. Okay, so you should be able to see the puzzle. And I've thrown the editor over to my other monitor so that we can run through the sequence of things. The first thing that was said was, now I'm going to move into solving mode, and what I'm going to do is I'm going to go 1, 2, 3, 4, 5, 6, and then I'm going to eliminate the ones from all of those, because that's the setup that our puzzle has achieved. And it says there's a less than between row 6, column 3, and row 6, column 4, which eliminates 6 from row 6, column 3, and 1 from row 6, column 4. So that's no longer a 6, and that's no longer a 1. Then it considers that pair, and that eliminates 2 from here. Sorry, eliminates 6 from row 6, column 4. It eliminates 2 from row 6, column 5, and 1 from row 6, column 5. So 1, 2, 3 is the minimum sequence there. Pointing cells in row 6, column 2, row 6, column 3, and row 6, column 1, removed 1 from here. So 1 cannot be here, so it's got to be here, so it can't be there. Less than between row 6, column 3, and row 6, column 4, eliminates 5 from row 6, column 3. Fair. Between row 6, column 3 and row 6, column 2, eliminates 1 from here. Row 6, 2 and row 5, 2 eliminates 2 from there and 6 from there. You can see basically how it's slowly cutting down these thermometers. Row 6, column 3, row 5, column 4. Row 6, column 3, row 5, column 4 eliminates 1 from row 5, column 4. Hidden single at row 5, column 5. Less than row 5, column 4. Row 4, column 5 removes 2. removes 6 from row 5, column 4, and 2 from row 4, column 5. And that 1, by the way, has eliminated 1 from all of those. Less than between row 4, column 5, and row 3, column 5, removes 2 from row 3, column 5. Yep. And 3 from row 3, column 5. Yep. And 6 from row 4, column 5. Yep. So again, remember, it's only considering that pair. It hasn't thought about that at all yet. Pointing cells in column 5, row 2, and row 1. Remove 2 from row 1, column 4. Row 2, column 4, and row 2, column 6. As in, the only place for a 2 in this column is here, so there can't be a 2 in any of those cells. All of that is good. Row 5, column 4. Row 4, column 5. Eliminates 5 from row 5, column 4. Agreed. 6, 3, and 5, 4. Eliminates 4 from here. Row 3, column 5. And row 2, column 6. Eliminates 6 from there. Eliminates 3 from there. And it eliminates 4 from there. Nipsey. Where's my undo button? There. Right, let's go back and read that much more carefully. Between row 3, column 5 and row 2, column 6 eliminates 6 from 3, 5, 4 from 2, 6, 3 from 2, 6. That makes more sense. 4, 5 and 3, 5. That pair eliminates 5 from 4, 5. Yep. 5, 4, 4, 5 eliminates 4, so we're propagating that upper limit down. And then 6, 3, 5, 4 eliminates 3 from there. So effectively what's happened is we have reduced that thermometer to its 2 degrees of freedom. All that makes sense. Less than between row 5, column 3 and row 4, column 3. Eliminates 6 from row 4, column 3. Sorry, 6 from row 5, column 3. 2 from row 4, column 3. And 1 from row 4, column 3. Then we're considering those two. And we eliminate 6 from here. And then 3, 2, and 1 from there. Then we're at 5, 3, 4, 3. And that eliminates 5 from 5, 3. Now we are at 5, 3, 4, 2. So we're considering that pair. And we eliminate 2 from row 4, column 2. And 1 from row 4, column 2. Then we're at this pair. And we eliminate 6 from here. And 3, 2, and 1 from that cell. Row 2, column 2 in column 2 has a hidden 1. So that's a 1. Neither of those are 1. And row 6, column 3 now has hidden single row 6, column 3 in column 3. Right. So now there's no 1s anywhere there. So that one has to be the 1. So that's not the 1. pointing cells in box 3, rows 4, column 1. So row 4, column 1, and row 3, column 1. Remove 2 from row 5, there, and there. So the only place for 2 in this box is there. So none of those can be 2. Pointing cells in box 3, row 4, column 1, row 3, column 1. Remove that 2. And then we have a naked 3 tuple in row 3 in columns 2, 3, and 5. That's a 4, 5, 6 3 tuple. Very neat. So we can go here, here, and here and remove 4, 5, 6. Pointing cells in row 3. Row 4, column 2. Well, pointing cells in row 3. Row 3, column 2. Row 3, column 3. Remove 6 from row 4, column 1. So yeah, in this row, 6 has to be there or there. Now, later we'll learn that that 6 can't be there, but that's fine, hopefully. Naked 3 tuple in row 4. Yep, we have a 3, 4, 5 3 tuple. We can get rid of 3, 4, and 5 from those cells. Hidden single 5, row 3, column 5 in box 4. Row 3, column 5. Yep, the only place in this box for a 5 is there. Hidden single 4, row 4, column 5. No 4's there or there, so that's got to be the 4. Which means none of those can be 4 or 5. None of those can be 4, and neither of those can be 5. Those are the eliminations. Oof, right, pointing cells in row 4. Columns 2 and 3. Remove 3 from row 3, column 1. Yep. Pointing cells in column 6. Row 5 and 6. Remove 4 from here. Yep. Less than between row 3, column 5 and row 2, column 6 eliminates 5, leaving a naked single 6, which means none of those are 6, neither of those are 6, and neither of those are 6. Boop. Naked single 2 at row 4, column 6. Row 4, column 6. Yeah, sorry, that's 6. Obviously eliminates the 6 from there as well. Naked single 2. So, clear the 2s. That's not a 2. Those aren't 2s. Naked single 3. Clear the 3. Clear the 3s. Naked single 1 at row 3, column 4. Nothing to do other than eliminate the 1 from there. Naked single 2 at row 3, column 1. Nothing to do with that at all. Naked single 1 at row 4, column 1. Naked single 6 at row 4, column 4. Hidden single 6, row 6, column 5. Yep, there's no 6's in any of those cells, so that's a 6. Pointing cells in column 5, rows 1 and 2. Remove 3 from those rows 1 and 2. That's correct. Pointing cells in column 6 here. Remove the 5 from here. We could equally well have done that with those 2 pointing cells, but that's fine. Less than between row 3, column 2 and row 2, column 1 eliminates 6 from here, 4 from here, and 3 from here. Naked single 5 at there. Yes, so none of those, and that are 5. See, naked single 4, row 2, column 4. Naked single 5, row 1, column 4. Naked single 4 at row 3, column 2. Naked single 6 at row 3, column 3. Yeah, because that 4 eliminates from there, and there, and there. So that becomes a 6, which eliminates 6 from there. Hidden single 5, row 4, column 3. Row 4, column 3. There's no 5s there, there's no 5s there. That has to be the 5. That's not the 5. Naked single 3. Which means neither of those are 3, and that's not a 3. Naked single 4 at row 1, column 1. Sorry. What did I just do? I just did the 3 there. That was the, yeah. Less than between row 5, column 3. And row 4, column 2 eliminates 4 and 3 from here. Naked single 3 at row 2, column 3. Is that fair? The less than eliminated 4 and 3 from there. Yes. Why does it say that that is naked? I don't think it is naked unless... Oh, because the elimination can end up setting that. That is 2. So that's not 2. And that's not 2, and that's not 2. There's our naked single 3. Naked single... So eliminate the 3 from there and the 3 from there. Naked single 4 there. Eliminates the 4 from there. The 3 eliminated that 3 as well. Naked single 6 there. Yes. Takes the 6 out of there. Naked single 2, row 1, column 2. Naked single 3, row 1, column 5. Naked single 2, row 2, column 5. Yes. So we've completed those top rows. Naked single 2 at row 5, column 3. Row 5, column 3, naked single 2. Yeah, well, we dealt with that one. Naked single 3 at row 5, column 4. Four at row 5, column 1. 5 at row 5, column 6. 6 at row 5, column 2. 3 at row 6, column 1. 5 at row 6, column 2. 2 at row 6, column 4. And 4 at row 6, column 6. So it did actually solve the puzzle. And then, instead of noticing that the puzzle was solved, it attempted to perform a paired less than between row 6, column 3, row 5, column 3, and row 6, column 3, row row 6, column 3, and row 5, column 3. So it repeated, eliminates 1 from row 6, column 3, and then it broke. So for some reason it managed to make a double pair where the two cells were the same. And the answer, of course, is that that pair has been inserted twice into the list of cell pairs because we have multiple thermometers. And that's what broke it. Oh my goodness me. Oh my goodness me. Okay. I can imagine that that was pretty tedious for all of you, because it was pretty tedious for me. Simple solution. Let's go to the definition here. Here, you can see that we collect, for the cell pairs rule, we collect all of the relationships into a vector. So if instead of a vector we collected them into a set, would that work? Let's just try that and see what happens. So cell pair relationship doesn't implement hash. Go to the definition of cell pair relationship. Trying to remember which one hash needs. Hash needs equality, I think. Does it need EQ as well to be hash? It does. Okay. So hopefully in theory that will work. Yes. Okay. So now it's happy because it's not managing to combine the same pair from multiple lines. Obviously, if the relationship was different, then it would. So if, you know, there was a dot on a thermometer line, then it would have to include that pair. But that's fine because that's a different kind of relationship. And so hopefully won't be trying to apply after it's actually solved the puzzle. Woo! Right. What I'm less happy about is all of this mention of less than. I think it would be better if that talked about the thermometer rather than the fact that it's less than. So I'm just going to run cargo test. We're good. I'm going to add the other thermometer puzzles that I came up with. So Swirl of Steam is also from the advent of Sudoku, but this time I'm just going to grab that and then grab the JSON, because I don't really think that we need to solve this one ourselves this time. Swirl of Steam. And this puzzle, Galactic Map, is also part of the advent of Sudoku. And again, let's just get the solution in place, save it, clear it. JSON. Kaiji bin end to end. Galactic Map and Swirl of Steam. Let's hope that all of those solve. They do. Right. So we are going to add Kaji rules. We should add all of Kaji rules. And that's just basically added the thermometer capability in and switched cell pairs to be a hash set. Cell pair rule deduplicates. Because that's effectively the reason that we're doing that. Kaji rules, add thermometers. Kaji loader support thermometers. And then add thermo puzzles. Okay. Before we go ahead and try to do this German Whisper test puzzle, we're instead going to teach the cell pair relationship stuff, what's going on with phraseology. I can do good phrasey brains. Exactly what's going on with the names of things, so that we're not. So when we see cargo run here, when we see this less than operation, it just says thermometer from X to Y eliminates blah. So let's go ahead and add support for that. So let's close all the buffers and grab up the cell pair constraint. Because in practice, the cell pair constraint and the double cell pair constraint need a name. So we're going to have name. And we'll capture the name. And we'll worry about all of the hideous numbers of problems that will come up in a bit. But now, instead of computing this complicated name here, we're going to generate the name externally. And so we're just going to start our logical step with self.name. So let's yoink all of that away and do borrow self.name. And stick a space after it. And we're going to have to do the same for cell pair relationship. Sorry, for double cell pair constraint. So this is going to make in fact, let's be slightly more. What's it here, just in case. It's an import into string. Let's do the same up here because it's only polite. And here in the cell pair constraint, here's where we perform the paired operation. So again, we're going to get all the way down to there and call that self.name. Right, go to a diagnostic. No, go to, no, there we go, go to diagnostic. No, all the diagnostics, here we go. Right. So cell pairs rule now needs names in order to be able to do useful stuff. So we're going to say that there is a name associated with every cell pair rule. I don't know why I said name there, because I'm really doing well. That should be string. And that should be name. And here the relationships are going to need to say string, which silences a lot of stuff. And now, of course, we need to use 1 and 1 and 1 and 2 and 2 and 1 and 2 and 2. I really should have just done names, but never mind. 1, 1, oopsie, 1, 2. One, two. 1, 2, 1. 1, 2, 1. Right. And finally, we're constructing the double constraint. So we need to make a new name. And that's going to be name. So f name. If first.0 is equal to second.0, first.0, else format and 1. And of course, we need to shift things across. So 0 becomes 1, 1 becomes 2, 2 becomes 3. 1, 2, 3. And finally, here, we're doing the negative relationships. And the negative relationship we're going to have to construct the name for. Or we can have cell pair constraint, so cell pair relationship, have a negative constraint name. Yeah, let's do that. So go to the type definition. So cell pair relationship has a format display. Yeah. What we can do is we can add a pub fn neg name, which is going to be format actually no, because match self. So a negative less than is explicitly a greater than relationship. A less than or equal to is explicitly a greater. So negative less than is greater than or equal. Less than or equal to is greater than. Difference D, if D is 1, is non-consecutive, else anti-difference of D. Sum of n match star n if they sum to 5, then this is anti-v. 10 is anti-x, and anything else is anti-sum of n. And then ratio r two is anti black dot, and everything else is anti ratio of r. So that gets us our negation name. Let's build our negation name. Let's name equal neg dot neg name. There's no point doing that. We can just pass neg dot neg name in as our first argument. Okay. Cannot move our name out because it's yes. Okay, so can't do that borrow there. I have to stick them there instead. Doesn't like me doing that. Okay, and we get the same thing here because we can't move it out, so clone it. And now we're down to the fact that, of course, building these relationships all the way out here are important. So the positive relationships that we have here need names. We build these positive relationships from white dots, black dots, and so on. So let's do that. So relationships. We need to pull up the puzzle data because our pair relationships data, Ralston pair relationship, needs to have a name. Rels.relationships.iter. R is a raw Sudoku relationship. So we should be able to go r.name.clone, which shuts up that bit. Now here, we need to describe the minimum cell. So the minimum cell is going to be builder cell info cell and we need to push there. Now again here, so let's copy that, pop it here. We're now doing a maximum cell. So that gets us our minimum and our maximum. We now need to name our thermometers. So let's name equal format thermometer from to thermo 0.1 thermo 0.1 thermo iter last unwrap. Just going to we know the thermometer is at least one cell long, therefore start and finish are good. Start, finish, push the name. There we go. Okay, now we get to build the so now we're in the fpuzzles converter. So we need to put names in for these things, and the name here is XV pair value between that's XV pair dot value, and then I don't know what I can do at this point. I can go copy down, go across, yank it, paste. What did that do? That's not what I wanted to do. I'm very good at this one. Copy. Yank. Yank. Join. Paste. Close paren. Comma. Comma. That's described the X and V. So now we have difference cells. So these are white dots. White dot. N between so well we know white dots are one. No, so diff dot value dot unwrap or 1. I think I'm probably just going to be quicker to type these in by hand. There's our white dots. Now we get to do our black dots. And in fact, this time I'm going to try pasting that in, but replacing diff with ratio. I'm getting better at helix slowly. Maxima and minima and thermometers don't need changing. We've got rid of all of our warnings. Now if we cargo run, we actually get it talking about thermometers from there to there. Oh, that cell pair can be eliminated from the description that we generate. So we don't need these. There we go. So thermometer from there to there eliminates 6 from there and 1 from there. That's good. And does everything that we are hoping for. And if we run one of the crop key puzzles. So if we do a cargo test, okay, no capture, then we can see that we're seeing white dots. That's it. We don't see any mention of black dots, which is a little worrying. Did I fail to do that right? Go next. I did. Ratio here. Word change black dot. That's better. Black dots and white dots. And sometimes we can see here a combination of a white dot and a black dot causing an elimination. That makes me very happy. Okay, we have now named things. Add fancy names to cell pairs. Which means we can move on to whisper lines. So let's grab this. So German whispers are lines along which pairs of cells have to have a minimum difference. This is not a cell pair constraint that we've actually coded up yet. If we look at the JSON, we can see we get whispers. We also get line, which shows the green bit, but I don't think that's relevant to us. We're just going to have something to ignore that somehow. We get whispers. Each entry in whispers is a line, so it's like fpuzzles lines, but there's a value associated with it, and that value is the minimum difference between adjacent cells along the line. There is also Dutch whispers, and if I just pop a Dutch whisper in and pop onto the JSON, you can see that one has a value of 2, where all the German whispers had a value of 3. And in practice, on a 9x9 grid, the German whispers minimum difference is 5 instead of 3, and the Dutch whispers minimum difference is 4 instead of 2. But let's see how we solve this. So we know along each of these, we're effectively going to be alternating high and low, because we've got to have a difference of 3. And we can't have 3 on the puzzle, which means that, so on this line, which means that we're looking for, 1, 2, 3, 1, 2, 4, 5, 6. That one can't be a 1. So if we just purely operate by elimination, then we can say that because this can't be a 1, that can't be a 4, because the smallest that can be is a 2, which is 3 away from 5, so that's not 4. And we can keep propagating these things around. So in fact, if I switch over to the solution path and we step, you can see that initial operation happening there. And the first step it says is placing a 4 in row 1, column 2 causes a contradiction. Row 1, column 1 has no candidates. As in, putting the 4 there would require that to be the 1, which it can't be. Therefore, it removes that 4. We would do it the other way round, but no, we would do it effectively that way. We would say that none of those values allow a 4 to be there in our pair computation. And then, these things propagate around these lines until you eventually get a 6 there. And then that line clears out. That line clears out. That line clears out. We can see the bottom right line happening, and eventually the bottom left line. So hopefully we can express that as a paired constraint. So let's solve it. Let's save that solution and clear it. And let's grab the JSON. Now I've just called this German whisper test 1. So sample puzzles, German whisper test 1. So we failed to load because we don't understand line. So we want to go back to our fpuzzles loader. And we don't really care what's in line, but we need to tell Serde that it's fine for it to be there. So let's go and stick this like over here, and we'll just go cosmetic content, which we can ignore. Line is a vector of Serde JSON value. And we can derive, no, we can set a default on that. And this is never read. Yes, well, we'll stick pub on it, but nobody's ever going to use it. And now whispers is what we need to do. So Serde default pub whispers. And we said effectively it's an fpuzzles lines object, just with that additional value field. So now when we try and load it, it loaded because fpuzzles lines doesn't have a value field. So let's stick Serde deny unknown fields. And now we say we have this value that we're missing. So value is going to be an option. Usize. I don't know if we'll ever get a 0 there. And now this is erroring out because it got a string and it expected a usize. It is in fact a string and not a number. Why? I do not know. That seems so weird. But it is. So we need to handle that. How can I handle that? Let's see whether or not there is a way to say, I want you to automatically convert this. So there's a deserialize with. Let's just do that. So let's say deserialize with takes a path. Function must be callable as that. Fields used with deserialize with are not required to implement deserialize. Goodness me. Deserialize with equals fpuzzles number d. Oh, goodness me. Result takes one generic argument, two generic arguments were supplied. So that's got to be a stud result. Result. There is no T here. That's okay because that T is going to be a usize. And associated type error not found for D. Cannot find trait deserializer in scope. Import survey deserializer, and that will shut up. Good. Okay. So what we want to know is whether or not it's a string or a number. We just need a value. So we can deserialize any. Oh god, this is getting horrible. Surday is not nice. Amos would be proud of me for saying that. So let's just do the simple thing here and make that a string. I think it's disgusting. We'll have to parse it later, but fine. Okay. Let's grab our converter. For whisper in val.whispers. I'm going to assume that value will be set for whispers, and so I can unwrap it. So I'm just going to go diff as an i32 is equal to whisper.value.unwrap.parse.unwrap, because we don't have any error returning of value from this conversion, so fine, we can panic. Panicking is fine for our mess. We now need to push this whisper into the puzzle data. So let's teach our puzzle data about whispers. It's going to be a vector of i32, vector of usize. So this is the difference, and then row and column. Go previous. Grid, rules, mute, whispers, push, diff, whisper dot line, for line in whisper dot lines, into iter map. Given a cell, c dot row, c dot column. Close that, close the map, collect it. So that's pushing the whispers into the puzzle data. And right. Now we need to turn those whispers into different cells. So rules Sudoku. So we have our whispers, and what we want to do is we want to try to name the whisper. So what I'm going to do is I'm going to Gonna stick oh, for goodness me, I can't type today. Difference and line in raw rules whispers iter match star diff and raw dot size. And the reason that we want to do this is because the different sizes of grids give us special names for two kinds of whispers. So if we have a 3 difference on a 6 grid or a 5 difference on a 9 grid, then our name is German Whisper. If we have a 2 difference on 6 or a 4 difference on 9, then our name is Dutch Whisper. And for anything else, our name is Whisper diff from. And then we need to make that mutable so that we can now push in the beginning and the end of the line. So the start is line 0. The finish is line iter last unwrap. And so name dot, tell you what, let's not let that mutable. Let's just go let name equal format name. And now I can get rid of those. Name from to where the extra things are start 0, start 1, finish 0, finish 1. So that is our line. And now we can insert those into the whisper pairs using the same structure that we do for everything else. So we can go for cell A, cell B in line dot iter dot copied dot tuple windows. So now we have our 2 cells. Cell A is rows, cell A dot 0 dot 1. Cell B is rows, cell B. So that's got our cell indices, and so now all we need to do is we need to say whisper pairs push name.clone cell A, cell B, and cell pair relationship colon. So we've got difference, which is difference equals. We need a diff at least of diff. And that's going to complain because there's no such variant. So let's generate that variant. and teach the system what these mean. So diff at least n difference of at least. I'm going to say whisper pair actually. No, difference of at least n. And the negative name for that what do we suppose that's called? Anti difference of at most n-1. Probably. I think that's reasonable. So we've now taught it all about that, and the only thing that's going to be left is that we need to implement the comparison, because if we try to run right now, then we're not covering the instance of it. Yes, I did. Good. So if we come across to the cell pair constraint, then it's this satisfied function that we need to fix up. So let's go to the definition of that. Here we are. So diff at least n implies a minus b abs is greater than or equal to n. Okay. Didn't manage to do anything. Same bug as before. We created the whisper pairs, we didn't actually use them. Success! Hooray! And we can see messaging here like this German whisper eliminates that, and so on. So I say that we have succeeded. We've got German whispers, we've got thermometers. Let's add our German whispers support. So Kaji rules, add add whisper lines. We should add the test case, and the whisper thing was called whisper test 1, I think. German whisper test 1, which is fair because it's not a Dutch whisper or any other kind of whisper. Cargo test. Ooh, I broke the thermo. Just one of them. That's fascinating. But the whisper works, so let's make this commit. And now let's work out what we've broken. Case 12 thermo panicked at pointing. That seems weird. Because this is the same panic that we saw that we fixed when we stopped this kind of thing from happening. So clearly it's trying to do an elimination when it really shouldn't. Row 6, column 3 to row 1, column 1. And thermometer from row 6, column 3 to row 3, column 3 eliminates 1. So that's that same situation where it was basically considering this thermometer and this thermometer together, and thus eliminating the one from there. I don't understand why it's doing that. It shouldn't, well, number one, it shouldn't need to because the puzzle is solved. But number two, it shouldn't even have chosen to do that because those don't share a box. So we're going to have to think about why cell pair relationships pick that up, but I think we're going to say that that's a problem for next time. So next time we're going to try and diagnose what's going on here. For now, everything except for this weird case is fine. I'm just going to run cargo test a few more times. Yeah, it's always just that one. Joy. Right. Well, that's it for today. And I will see you next time when we will try to solve that bug. Bye for now.